Okay, now today, okay, I would like to show you some mathematics that's useful in physics. Okay. The first thing I'm going to show you is about the proportional sign. Okay. So it looks like this. Okay, now, um, okay. Now most of books, you don't, well, it's not a requirement of year 11 physics for you to understand this, but to understand that it really helps you to read an equation. So, for example, if I give you an equation, something like, um, okay, let's use this equation, the equation from your book. Okay, the gravitational force between two objects. Okay, now if you look at this equation, okay, we have a force, okay, and I have a radius here, means the distance between the two objects. Okay, and what I can say is I can rewrite that equation. Okay, if I assume gravitational constant, this number, and this number, if I assume these three numbers are constant, okay, are not changing, I can rewrite this equation as this. Okay, now what it tells me is, okay, so what we can say that is force, okay, is inversely proportional to r squared. Okay, what does it mean? It means, okay, let me use red. Okay, it means, okay, as the value r squared increases, okay, the force F must decrease. Okay, so from this equation, r means the distance between two objects. So as the two objects get closer, the force would increase. That's what it means. Okay, or the other way around. Okay, as F decreases, okay, r squared must increase. Okay, that's inversely proportional. Okay. However, if I show you something, um, something like, if I show you another equation, say, uh, well, just give me a second. Okay, so P equals to VI, what we just did this week. Power equals to voltage times current. Okay, now if I assume, okay, now if I assume, well, I should do that around. Okay, now if I assume the voltage is unchanged. Okay, now if I assume the voltage is unchanged. Okay, so in a particular situation, the voltage doesn't change, and I don't think, yeah, okay, well, yeah, it's not a good example. The voltage always, normally they would change, but just let's assume something like this happened. I can rewrite that equation in this form. Okay, so it means this is, okay, now this is means the power is directly proportional to current. Okay, so what it means is just in contrast to this one. Okay, in here, okay, I have 1 on r squared. The r squared is the denominator. In here, the denominator will be 1. So that's why it's different. Okay, so it means as current increases, okay, my power must increase. Okay, or as the power increases, okay, so the current must increases. Okay, or the other way around, as current decreases, it must decreases. So, yep. Okay, so that's what this thing means. Okay, so use this kind of information. Try to do question 4 in your weekly assignment.